Okay, so we are going to talk about arrays today. So last time I talked to you about strings. Today I'm going to tell you about arrays. Okay? So do you want to know why the programmer quit his job?
Why?
Because he didn't get a raise. Alright, I know. Alright, so we're going to talk about arrays today. Well, let's have a look at what the book has to tell you about arrays and why we want to use arrays. Alright, so if you look at the summary that I have, huh?
Let's turn off the lights.
They want us to leave it open because the
Circulating
AC's out in there and the server is in the room and they don't want it to overheat. Okay, so we already have discussed the so-called primitive data types. So let's say you have int A1, A2, A3, and then you want to go and make like 1,000 of these variables, right? Obviously that is pretty time consuming. You wouldn't want to do that, right? And fortunately, there is something called an array, and that allows us to declare a whole bunch of things in just one simple line. Okay? So instead of doing this on the top, what I'm going to do is I'm just going to do, let's have a look at the syntax of this. Okay? So I just do int a square brackets and where is it this way? Max vals. Oh, let me double check real quick. Right, so I'm gonna do a 1,000 just like this, right? And if you're in Sublime, you can just do Control B to see if this works. No, it doesn't like it. That's not the syntax. Let's try is equal to new int. Let me double check. Let's just go straight to the book so I can remember the syntax for this. Okay, so the bottom line is we're going to be able to do something like this. Of course, my syntax is not right now, but I'm going to fix it in a second. Right? We're going to do something like this that's just going to declare a list of 1,000 integers. Okay? Just like that. So let's have a look at this real quick, right? So the primitive data types that we've had to deal with so far are int, char, double, float, string, right? Those are the so-called primitive data types. On top of that, there's other data types, and the one that we're going to talk about is arrays, okay? So, and what is an array? It's just a list of numbers or a list of characters or a list of decimals or integers or whatever the data type is, but it has to be of the same data type. Okay, and each of these is identified by a subscript, right? So if I wanted to identify A1, I would do something like A0. Okay, if I wanted to identify A2, I would do something like A1. Okay, it always starts at 0, so just keep that in mind, and it's the same in all programming languages. So whatever you're learning here is going to apply in C++ and PHP and Python, whatever. Okay, some languages allow you to make arrays of different kinds of things, but Java and C and C++ and a lot of these languages that derive from C, they only want you to do it of one kind. If you want to make it like an array of different types, then that is something that we're going to address in the data structures class, which is the one after this, the CSIS 27. Okay?
What happens if you start with 1 instead of 0?
Then you will just be telling it, go look at the second one.
Oh.
Right? So the first thing on the list or on the array is always the 0. Right? And even though I am declaring a list or an array of 1,000 things, right? This one here is the first element. This one here is my second element. Okay, and the number that you're seeing here, this here is my index. Okay, so those are the terms that you need to remember. So this is here. What I'm doing is I am declaring an array of the integer type of 1,000 elements. Right? It's going to be 1,000 things in it. The first thing is going to be 0. Second thing is going to be 1. And if I want it to go on the same way, the last thing is going to be, what do you think? 999. Right? So since it starts at since it's a 1,000 things and we're including the 0, the last one is going to be 999. Okay? This is the last element. Okay? So the last element is always one less than however many things you declare this to have. Okay? So that's the main thing. Know what an element is, know what an index is, know what an array is, right? Know what an element is. That's about it. So let me do like that. Okay. So let me just keep going through this, right? So these are the different elements. You basically just declaring, you're telling it there's going to be a whole bunch of different places in memory, and we can identify different places, these different places, which are all going to be of the integer type. If I declare this as an integer array, by their indexes, okay? Or also known as the subscript. Different languages call it different things. Okay, and here's the actual syntax. All right, so let me go and fix it. So what I'm going to do here is I'm going to change this thing to a like this. Okay, declare an array of the integer type. That's this piece. And the next thing is I'm going to say a is equal to new, let's go with a double, right? Because it's a double. All right, let's just stay with what the book is showing. So these are going to be all doubles, right? And of the double type. Okay, is equal to new double square brackets 1,000. Made it too many, right? So that's an array of 1,000 double values, right? So there's one way for you to do it on two separate lines. And if I wanted to do something similar, I can do something like double b square brackets is equal to new double square bracket 1,000, right? Both pretty much do the same thing. So this one here does the same thing in one sitting, in one line, okay, of 1,000 elements. Okay, so you can do it in one line, you can do it in two lines, whatever you feel like, whatever the application calls for. Okay. By the way, C++ calls this dynamic memory allocation, which means we're deciding how big the array is going to be at the time our program is running. You can't tell the difference right now, but right when you're using new, that means you're doing dynamic memory allocation. Okay, but Java really doesn't go into that kind of stuff. Okay, it's because everything is done the same way. All right, so this is an array of 1,000 doubles. I'm going to do control or command. If you're on a Mac, you do command B to try to compile this thing. Ooh, it's a whole bunch of mess. Okay, because I forgot my semicolons. Okay, so I'm going to put little comments in front of this, in front of this, in front of this. A little space in there. Okay. All right, so let's have a look at what is in my array initially, right? It should be a bunch of zeros because Java is a very nice language. It should make an array of a whole bunch of zeros, right? And we can show these things, right? So what I'm going to do now is I'm going to show the elements of the array, right? I'm going to do just system.out.println, and I'm going to show you that a square bracket 0 is equal to plus a square bracket 0. All right, I'm going to save this thing. I'm going to build it. Still doesn't like it. Compatible types, double, double. This has got to be a capital double. You got to be kidding me. No, no. Got to make this a double too. Capital D. Now it likes it. Okay. Question?
I thought the error was something with the D function.
No, it's just it wants a double with a capital D. Yeah, don't ask why. Okay, that's what it wants. And this is something that a lot of languages. I'm not big on remembering the syntax, as you can tell, right? The most important thing for me is know how to use it, know how to know where to reference it, and then the rest is just, when you have like a bunch of tools in your toolbox, I'm not gonna teach you how to use every single wrench. I'm gonna show you one of them. If you know how to use one of them, you can figure out how to do the rest of them. And this is something that's applicable to programming languages. If you learn one, if you learn a couple, then after that you can pretty much teach yourself the rest of them. Okay? But you should have a couple of them under your belt first before you can start teaching yourself, unless you're really smart. Okay? Or you have some kind of inclination towards programming. Okay, so this works. Let's double check that it will show me something. So I'm going to do Java. I already compiled it, but let's compile it one more time. This is arrays, Java. All right, it's happy, Java, arrays. Right, and it actually shows you it's null. Okay, that's fine. So I'm trying to show you the first one. The first one is null. What is null? It's like nothing, basically. Okay, and if you end up sending me emails, you're going to see that my email is null dreamer. Now you know why it's null dreamer. All right, so that's let's try the A1. It should also be a null, also, hopefully. All right, build it, and I'm going to compile it and just run it from there. They're all nulls. Okay, so when you make an array, okay, each array element is going to be equal to null. Right? You have 1,000 nulls. All right, and what is a null? It's like a pointer to nothing, basically. Okay, all right. So this is the showing the elements of the array, and this thing shows, right? Shows no, right? Shows no. And one thing that's really cool about the array is you can figure out, you can use a loop to do this thing, right? So let's do this. For int I is equal to 0, I is less than 1,000, I plus plus, and I'm going to system out print line, throw that in there. Instead of this here, I'm going to close my quotes. I'm going to do a plus in there, plus after. I'm going to change this to I, and I'm going to do this here, I. Okay? So what I'm going to do is, instead of going in there and manually handwriting, typing a bunch of, numbers, I'm going to have the loop, insert the number for an index for me, right? This piece right here is going to be just a label. This piece after it is going to be the actual array, right? So what is it going to do? It should show me 1,000 nulls. So what I'm going to do is I'm just going to do print, which lets you write on the same line, so it doesn't do 1,000 new lines, with a little space after that. I'm going to save it, I'm going to build it, I'm going to go back to my command line and run this thing, and you can see it. It's 1,000 nulls. Alright? If you're not convinced, I can scroll all the way up. Right? It's 1,000 of them. It starts at 0, that's the first one, and it goes to, you guessed it, 999. Okay? And the 999 is just the value of I. I goes from 0 to 1,000, 1 less than 1,000, of course. Okay, so this is how you can show an array using using a loop. Okay, what if you don't know? Well, let's leave it like that for now. And by the way, the array object itself has a way for you to check how many things are in it. Okay, but we're going to get to that in a second, before after I get all the other stuff out of the way. Okay? So, the next thing that I want to do is show you how to change an array. Right? So now you know how to show an array, right? Show the elements of an array. And the next thing I'm going to show you is change the elements of an array. Okay? The easiest thing to do is you just say, all right, hold on, A0 is now equal to some double value, let's say 3.14, and then A1 is now equal to 2.17, or what is it, 2.71, Can't remember what E is. All right? And then what I'm going to do is I'm going to grab this thing, the way that I showed this to you, throw that in there, and now it should show me these new values that I stored into the array. Okay, so I'm going to build this thing from Sublime, go into the command line, and let me just clear screen, and oops, clear, right? And then run it, and now you're going to notice that I should do another system.print line. Let me get this in here so we have a new line going. Builds, run, right? So it shows you that these two new values, right, which it was all null before, now we changed the first two values of the array, or the first two elements of the array, to these particular values. Okay, so changing an element is just as simple as, you know, writing the array name, right? Again, this is your array name. Let me throw it in there. This is array name, and you already know that this number here is the array index. Okay, so that's how you change an array, the elements of an array. And by the way, you can use the same thing with the loop, right? We know we have 1,000 things, so I'm going to grab this thing, right? And what I'm going to do is, this time, I'm just going to make the whole array equal to a bunch of zeros. Okay? So I'm just going to go a square brackets I is equal to 0. Okay? So that is make the whole array equal to zeros. Okay? Now when I do Control S, Control B, whoops, what don't you like? I think it wants an integer. So let's go, double. We're going to do 0.0. Now it should be happy. It is. And I'm going to go in there and run this thing. And you're going to see that now I changed these elements to 0 and 0. Okay? I can go and grab this thing here. Grab my system.println loop. Right? So I can show you, right, that all of these are now equal to 0. Ta-da! Okay? Very easy. With just 2 lines of code, you can do a whole bunch of things which you would normally have to do a whole bunch of, writing to get done. Okay? So again, index, element, array, those are basically the things that you need to know. And let's have a look at what else the book has to tell you, right? So there's different examples in here how you can initialize an array. There's another way to do it. Right? Let's say I have this here. I'm going to copy the whole thing because I don't want to type it. Right? This piece here. Right? I'm going to go throw it in here like that. Okay? So notice in here and in here, I had to go and give it a number so it knows how many things are in the array, right? So that I can declare it of a certain size. If I do it this way, I don't have to provide a number. It will automatically figure out that there's 1, 2, 3, 4, 5, 6 things, right? 6 things in the array. Okay, and I can go in there and show you. Let me do a system.println again. System. This is going to be prices, right? And that thing should show you 10.96 for the first one. So let's have a look at this real quick. Control B. Run it again. And you can see prices is equal to 10.96. Okay? Any questions? Make sense? Okay. So that's that. Basically, and this here is, so again, you're declaring and initializing an array without providing specifically how many numbers it's going to be in it, but you're providing the numbers that are going to go in it, and it figures out the size automatically. Okay? Going down. Alright, so there's one-dimensional arrays, which is what I've been showing you so far. Alright? And you can use a loop to go through the array. Alright? And I guess the book goes into sorting algorithms, and I guess I'm going to show you that too. Alright, so the sorting algorithm that the book tells you about is something called a bubble sort. Right? So I'm going to grab this thing, and actually I'm going to take out all these different system.printlns. Right? So I'm going to get this thing, comment it out, get this one, comment that out, because I don't want to see a whole bunch of nulls and zeros and stuff like that. Okay? So here comes interesting stuff. Right? So let's say I have an int c, right? And this thing is equal to 4, 3, 2, 1. These are the numbers that are into the array, and I can just grab one of these loops. Why don't I? I'm going to copy this. I'm going to throw it in there. And this time, have a look at this real quick. Yeah, length. Okay. So what I'm going to do now is, let's say I don't know how many things are in the array, right? Because you're not going to always know how many things are in an array. Maybe you went and you read a bunch of numbers from a file, and you put them into the array one by one. You don't know how many. Okay? You can figure it out by just saying I is less than c dot length. That's it. Right? So again, the C array, which is an integer array, has a way for you, has a built-in method or a built-in thing that lets you know how many things are in it. Right? So let me just do a system out println so that you can see it. Print, yeah. This print ln, right? And I'm going to show you there are plus c dot length plus elements in the array C. Okay? Hopefully it works. Keep your fingers crossed. Okay, so compile this thing. Let me just compile it from here. Control B to compile. Go in here and run it. And let's look at C, right? There are 4 elements in C. A0 is this, A1 is this. Well, it keeps going as A. Let's go C. I don't care about A anymore. B, Control B. Run it again. Right? So these are the different values that I have in C. Right? 4, 3, 2, 1. Okay? So, what I want to do with this is I want to sort the array in ascending order so that it's 1, 2, 3, 4. Okay? So this is your introduction to bubble sort. So what I'm going to do is I'm real quick, I'm going to open a new tab. I'm going to go look at bubble sort. Right? Look at Wikipedia. Scroll down. And let's see the bubble sort in action, right? So you have a list of numbers or an array, right? And this bubble sort algorithm does one thing. It compares every numbers that are next to each other, and if the one on the left is bigger, swaps their values. Right? So is this one bigger than this one? Yep, swap their values. Is this one bigger than this one? Nope, leave it the same. Goes to the next one. Is this one bigger than this one? Yep, swap their values. Goes to the next one, and it goes to the next one until it gets all the way to the end. And by doing that for every set of numbers, what happens is the biggest number gets moved up all the way to the right. Or, why it's called a bubble sort, the biggest number bubbles up to the top. Okay? So once we've done this one time, we go back to the beginning, and then we start doing it again for every 2 numbers that are next to each other. Is this one bigger than the other one? Yep. Swap their values. Go to the next one. Is this one bigger than this one? Yep. Swap their values. So now when it does it the second time around, we already moved the biggest one all the way to the right. The second time it does this, it will grab the second biggest number, which is the 7, and it will throw it right here. Second place, from the right. Okay? And if you do this repeatedly for as many numbers as you have, you're going to end up sorting the whole thing. Okay? So this is what it looks like. And there's another way to look at this, and that is this picture right here. Right? So you have initially a whole bunch of data like this scattered all over the place, and you start sorting them from the largest to smallest until they're all lined up in a, in a sorted manner. Okay? That's the bubble sort. Okay, so now that you know this, keep in mind this little picture here. All we're going to do is we're going to compare it left to right. If the left is bigger, we're going to swap. Right? So we go in there. I already showed you this stuff. And I already showed you how the length works. I'm going to take this out for a second. Okay, so I already mentioned to you how the swapping mechanism works, right? But maybe you forgot. And let's have a refresher. So let's say I have an int a. Do I have an a? Let's call it x. And x is equal to 10. And I have an int y is equal to 20. Right? And what I want to do is I want to swap the values of x and y so that x is equal to 20, y is equal to 10. Right? How do I do this? Magic. Other than magic. Get a placeholder value, right? So I get something like temp going. Let me make a variable temp. So I'm going to have an int temp. All right? And I'm going to go in there. I'm going to say temp is equal to x, x is equal to y, y is equal to temp, right? And so what happens? Temp is equal to x. At this point, temp is equal to 10. X is equal to y. At this point, x is equal to 20. And y is equal to 20. And temp is equal to 10. Right? Then if I go to the next line, y is equal to temp. Now y is equal to 10. X is equal to 20. And whatever. Who cares about the temp? Temp is still whatever it was. 10. Right? But the bottom line is, I swapped them. I got what I wanted, which is this right here. Okay? That's what we're going to use for the bubble sort. Alright. Except we're going to use arrays. Alright? So it goes like this. So for these values right here, right, I'm going to go in there and doing the above with the array C. Okay? So I go in there and I do this. I say, alright, C0 is equal to, or the other way, temp is equal to C0. Then C0 is equal to C1, right? Make the first one equal to the second. And C1 is equal to temp. Right? Same thing that I did on top, except I'm doing it with an array. Alright? Except I only want to do this if my left is bigger than my right. So if C0 is bigger than my C1, only then am I going to do this little swap business. Okay, I'm going to get this, cut it, throw it in there, fix my indentation. Right? So doing the above with the array C, right? But only if the left element is bigger than the right element. Okay? That's the first one. Right? So this is me doing the swap for these first two. So after I'm done with this swap, right, instead of the original, which was 4, 3, 2, 1, what I'm going to end up being with is 3, 4, 2, 1. Okay, that's the first swap. Alright, so I'm going to grab this thing here now. I'm going to copy it. I'm going to paste it in here. Okay, now what we're going to do is we're going to look at the second two digits. We're going to look at the 4 and the 2. Is 4 bigger than 2? Right? So I'm going to change the 1 to 2. So 1 becomes 2. So it's easier to keep track of. And the 0 becomes 1. Right? 0 and 1. Right? And in case you forgot, you have your index. Index. The indexes are 0, 1, 2, 3. So what I'm doing is I'm comparing index 1 with index 2, which is the second and the third number in the array. Okay? So when I do this, now the 4 is going to go here. So I'm going to have a 4 in here. I'm going to have the 2 in there, hopefully. All right? 3, 2, 4, 1. Okay. So then I got to go and do this one more time for the last two numbers. Paste that in here. Right? So when I'm done with this thing, with the swap, the 4 should go here. The 1 should go here. Right? And again, I got to compare these two, right? Or these two, whatever you want to call it. Right? So I'm comparing elements 2 and 3. That means I'm going to just go and change the 2 to 3 first because it's easier. Right? 2 becomes 3. And then the 1 becomes 2. Right? So I'm comparing C2 with C3, which is these two indexes, the last two on my array. And if the left is bigger than the right, which it was initially, right, from the previous swap, then I'm going to swap their values, and it'll end up being like this. Does that make sense? Okay. Now, the problem is, I don't know how many things are going to be in the array. This is great for an array of 4, but what if I have an array of 1,000? Okay, I'm not going to go copy paste this thing 1,000 times. So, why don't I do this? I'm going to go in there, put a comment around this whole thing. Okay, and what I'm going to do is I'm going to go in there and say, all right, hold on, let me call this a variable, or this one right here. The 0, I'm going to call it I, right? And what do you want to call this thing here? The 1. How about I plus 1? Right? So if this is my I, the other one is going to be I plus 1. So on my next swap, right, this is going to be my I again, right? And on my next swap, here, this is going to be my I again. Okay, and the reason I'm doing this is so that you can see that I, right, I starts at 0, and the last value for I, for 4 elements, right, that means I ends at the length of the array. Remember, the array has a length. I showed you this here. So this showed me that there are 4 elements in the array, right? Okay. So what I'm going to do is this here, my last I ends at, what's the name of the array? C dot length minus 2. Correct? There's 4 things in it. Just to remind you, C dot length is equal to 4, right? 4 elements in the array, 4. Okay, so that means I is going to start at 0, and I is going to end at C length minus 2. You want to express this thing in terms of length because you don't know how many things are going to be in the array. Okay? We're trying to make like a general form of this thing. Okay, so now that I have this, I'm just going to go and say, all right, for int I is equal to 0, right? I is less than C dot length, right? I'm not going to do C length minus 2 because remember this, actually I'm going to go minus 1 on this. Or I guess I can go less than or equal to C length minus 2. Question?
Can you higher up the screen?
I can move up. There you go. Yep. Oops. Come on. There you go. Okay. So that's the idea. So when I do this for my array, I'm just going to say I plus plus in here, and I'm just going to grab this thing here that I had from before, and I'm just going to follow the convention that I established. This piece here, whenever I see a 0, I'm going to change it to I. Whenever I see a 1, I'm going to change it to I plus 1. So I go in there, I'm throw in my curly brackets, paste the stuff in there. Okay. Okay. Maybe I should have done this stuff first. Fix my indentation. Get rid of this stuff. Right? So this loop here, loop that does the above that I had commented out. Okay? Does that make sense? So instead of doing this a bunch of times, I wrote it a couple of times just so that I make it easy for me, right? I start with something simple like an array of 4 things, and then slowly I just write out the steps so that I can see what the pattern is, right? What's my I plus 1, and then after I establish my pattern, I say, oh, hold on, I starts at 0, right? And my I ends at C length minus 2, so I can make a loop that changes the I value for me. And then wherever I see a 0, I go I. Right, where's my other I? 1 in there. And another one here. Wherever I see a 1, I just say I plus 1, I plus 1, I plus 1.
Do you mind if it's a picture?
All right, go for it. Right? So, any questions? Make sense? Okay. All right. So if you don't believe this, let's pull one of these loops that I used to have with the for loop thingy. This here. Or no, let's get the one with the length. All right. I'm going to paste this thing in here. Uncomment it so that you can see the magic. Alright, I'm going to get rid of the label so that I can just show you the array. I'm just going to show you the value of the array with a little space after it. Okay? If I really want to, I can do a system out.print and I can do some curly bracket here and then I'm going to do another one after it. Let me copy this. Fix my indentation. Huh? No comments? Commas, no commas. We'll just leave it like that. Fine. All right. Well, it's just close enough. Control B to compile it. Go to this thing, run it, and there's my array 3214. Okay. So what did I do? I moved the biggest number to the right. That's the first step. Okay. So now what I got to do is I got to do this a bunch of more times, right? So I'm just going to copy this whole thing here, copy it, paste it, right? I'm going to save this, build it, go to the command line, run it again, and now you're seeing that the second biggest number gets moved, right? So we had 3214, and now you have 2134, right? So we moved the two biggest numbers, right, to the right. The next one, I'm going to copy this one more time, paste it, save it, and let me build it again. Go back here, build, go to this, run, and now it's sorted. Okay, so what did I notice? And again, I'm doing a similar thing to what I did before. You know, in order for me to easily visualize what's happening, I just start with some simple example. I do it a couple of times. So for an array, with an array of 4 elements, I have to repeat the loop 3 times, right? 1 time, 2nd time, 3 times, right? But again, I don't know if I'm going to be working with an array of 4 or 5 or 1,000, so I got to go and generalize this loop to happen as many times as there are things in the array. All right, so I wanted this thing to happen 3 times. And remember, this loop itself happens 3 times, right? So the reason I wrote this thing like the way it is like this is because I wanted this thing to happen 1, 2, 3 separate times. So if I was to just grab one of these loops, and what I'm going to do is I'm going to comment them out too, just like I commented out the one on top. Okay, I'm going to take this out. There, save it. Okay, so what I'm going to do now is I'm just going to grab one of these loops. Okay, I'm going to throw it at the bottom, right here. There. And then I'm going to go and make another loop. In fact, I'm going to grab this thing here. I'm going to copy it. I'm going to paste it. I'm going to change the I to J or something. Alright? So basically, this loop is going to happen as many times as this other loop because I just showed you that that's how many times it has to happen. And then I'm going to go in there. I'm going to add my curly brackets. I'm going to grab this thing here, put it in there, fix my indentation. Alright? And that's the bubble sort. Okay? This is your bubble sort. Bubble sort. Question?
Yeah. Do you need the curly brackets for like the outer loop? Because the outer loop
You don't need the curly brackets because there's only one thing inside of the outer loop. Right? And actually, you don't even need the curly brackets for this guy because there's only one thing in it, which is the if. Right? So you can get away with just this. But let's go put the curly brackets, not to confuse people. Okay, so I'll leave it like that, save it, and now I'm going to go and run this thing again. And if what I'm telling you is true, it will still sort it the same way that I did before. Okay, so I'm going to get this thing, save it, build it, still works. Go to back my terminal, run it, and it sorts it. Okay, any questions? Okay, so let's go back to the little, whatever I have. Wrong one. Okay, so that's the bubble sort that the book has, and different pictures in there to show you that stuff. This one here is an example of how we can enter information into an array. Right? Yeah, what's wrong with this thing? Oh, I didn't pull down the screen, huh? Okay, so this here is an example of how you can enter a bunch of information into your array, right? So we're declaring an array of however many things, 5 things. We're going to have a loop that happens 5 times, and we're going to ask the user 5 times to enter some information using the little dialog box, and whatever number they enter goes into the array. Then there's another loop in here to show you the array. This also is an example of how to sum up the numbers into the array. Right? So let me go back to my little code here that I have. Right? So some of the things, other than sorting an array, you should be able to find, right? Finding the sum of all numbers in the array. Okay, and that's easy. You just go, all right, int sum. Did I go with int? Is this an int? It's an int. All right. So int sum is equal to 0. And I'm just going to grab this loop to recycle it, copy, paste, and I'm going to say sum is equal to sum plus ci. And that's it. I can do plus equals. This is also known as sum plus equals ci. Right? One or the other, whatever you like. I like the second one. I like this one because it's shorter. Okay? But let's leave it like this for now. Alright? Questions? Still make sense? Okay. Some other things that you're supposed to know, and the book shows, is how to find min and max. How to find the smallest and largest number of things. Right? And let's say we didn't sort this thing. All right, let's start with a different array. So I'm going to go in there. Let me just copy this thing. And I'm going to throw it at the bottom. Okay. I'm going to make a new one, call it D, right? And it's not sorted. Let's say we have a 3 in here, and the 4 is in the middle, and the 1 is in the middle. Right? It's just in some total random order. Okay? So instead of sorting it, we're just going to go through this thing and find the min and the max. All right. So finding the smallest and largest. Let's go with smallest. Smallest value in the array. Okay? So the first thing I'm going to do is I'm going to make a variable called int smallest. And what I'm going to do is I'm going to make smallest equal to the first element on my array, right? So I go d square brackets 0. Okay? So make smallest equal to the first element. Yes? Okay, the next thing that I'm going to do is I'm going to compare smallest to every other element, and if any other element is smaller than smallest, make smallest equal to that element. Right? So I'm going to make my loop again. I'm going to grab this thing here and recycle it again. Copy, paste. Right? This time we're working with D, so it's d.length. Everything else stays the same. I'm going to throw in some curly brackets just because. And it goes like this. So compare smallest to every other element. In fact, I'm not going to start this at 0 because there's no reason for me to compare the first element to itself. So I'm going to make this equal to 1. I'm going to go here. And if any other element is less than my smallest is equal to my array element. Okay? So let's say, look at this thing here. So initially smallest is equal to this, right? Smallest is equal to 3. What we're doing is we're going to look at the next one. We're going to say, all right, hold on. Is 4 less than smallest? No. Is 1 less than smallest? Yeah. So if that's true, which it is, make smallest equal to 1. Then we're going to go to the next one. Is 2 less than smallest? No. Stop there. Right? So it just goes in there and picks the smallest value, retains it, and then that's it. Questions? If you don't believe it, let's do a system out println. Show you that. Okay. Print ln there. And this is ln again. And I'm going to show you smallest is equal to smallest. Alright, save it, build it, hope for the best. And there you go, smallest is 1. Okay? How do you think you find the largest? Same way. So you go in there, let's say, alright, int largest is equal to d0. Okay? And I'm going to have different if here. If my di, if any element is greater than my largest, then largest is equal to my element that was larger than it. Okay? You can grab this thing, copy it, show you. Alright, largest, save, build, go to the command line, and run this thing, and there's your largest. Okay? Smallest, largest, that's it. Alright, so, let's see what else. String arrays, yeah, so you can have arrays of strings. Like I said, it can be characters, could be integers, could be doubles, could be floats, right? Strings also. Runtime dimensioning means that you're going to give the dimension of the array as the program runs. That's the dynamic memory allocation that C++ calls it. Okay, array initialization, I already showed you. You can do it this way, right? Deep shallow copy, right? So the first is shallow copy, which creates a pointer to the original array. So both arrays share the same memory storage, which means that if you change one of them, you change both of them. So if I go in there and I have an array E. So let's say E int E square brackets, and I say E is equal to D. See if it takes it. Yeah, it likes it. Okay? If I do this, right? So my D array is this, 3, 4, 1, 2, right? If I go in there and I say, all right, well, hold on, E3, which is the last element, is equal to 300. Okay? What I'm going to do now is I'm going to get this whole thing, copy, paste, and I'm going to show you E square bracket 3 is E, well, let's not do the E, let's do D. D3. Okay? Save it, build it, go back to the command line, run it, and see what I did? I didn't change D directly. I changed the array E, right? But because I did this here, this is my shallow copy, right? Changing one array changes both arrays. Okay, so both of these E and D refer to the same places in memory. Okay, so if you change one of them, you change the other one. That's the shallow copy. There's another way for you to create a whole different array so that it is not referring to the original one, right? And that's the deep copy, right? The deep copy is this right here. All right, so you basically tell a system.array copy, blah, blah, blah. Source is the source that you're copying. Start index is where you're going to start. Target is the target array. Start index, again, where you want to start copying into. And then this here is the number of elements that you want to copy. Okay, so there's another way for you to copy this. And if you want to look at examples, look at page 419 through 420 in the book. They will show you this. Okay. The array searching and sorting. I already showed you how to do a bubble sort. The bubble sort is not the most efficient of sorts. There's other sorts. There's quick sort. There's insert sort. There's select sort. I don't know what else. There's shell sort. There's a whole bunch of other sorts, right? People went in there and got PhDs in figuring out clever algorithms how to sort, right? So these are not trivial. The bubble sort is a very easy one to visualize and to get you started with, but it's actually the slowest one of all of them. There's other ones that are much faster. And the one that is built into the Java itself, the sort thing, is a faster one. Okay? There's also ways for you to search an array, binary search. What's a binary search? Binary search means what we're going to do, let's say I'm thinking of a number between 0 and 100. What will be your guess? 50. You always go in the middle, right? All right, so I'm going to tell you, no, it's lower than that.
25.
Then you go, so now so you're going between 50 and a 0. Half of that is 25. I'm going to tell you, no, it's higher than that. So now you got to go between 25 and 50, whatever half of that is. So all right, so it's 37. And then you go, all right, well, it's half of that. So the idea of the binary search is that if I told you, oh, guess between a number between 9 and 100, and you start at 0, if my number is 99 and you keep guessing them 0, 1, 2, 3, 4, you're going to guess 99 times. But if you're doing the binary search, it takes no more than 7. The worst case. All right? So it's a lot faster, but that's why you would want to have the thing sorted in the first place. Okay? So these are the things that are built into the language and that you're going to have to do some assignments with them. All right. Arrays as arguments. All right. So let me go back to this here, and I already have it written. If you actually go in there, this little file right here, that is what I'm looking at here. All right, so I'm going to go in there, and I'm going to go and get my show array, because I don't want to write it again. Copy it. I'm going to throw this thing right here. Okay? So what am I doing? I'm creating a method, public static void show array. I'm calling it static so that I can call it directly without making an object. Okay? Show array is my function name or method name. Void means it's not going to return anything. Int a is my parameter. Right? So I'm sending the whole array into my method. Okay? What I'm going to do is I'm going to show you the array through the method. All right? So it's like a general method that will work for any kind of an array. And it's going to show you any kind of an array. So I'm going to go in there, and I'm going to show you, what is it called? Show array. Hard to remember name. I'm going to go in there, paste this. All right, that's my function call, and I'm going to send the array E, just like that. Okay, I'm not putting square brackets. I'm not doing this kind of stuff, right? If I do this, then I'm telling it send only an individual integer. And if I did that, then see what it does. No. All right, blah, blah, blah. Incompatible types. Int cannot be converted to int. So basically, I told it in here, we're going to have an integer array as a parameter, right? And what I'm doing here, I'm sending over a single integer. So it's telling me, wait, hold on. You're sending a single integer. You can't. You have to send a whole array. So how am I going to send the whole array? Just like that. All right, build it. Question?
Yeah. What's the difference between this and doing like E dot?
E dot?
Like calling functions with like the E dot show array or something like that.
Oh, okay, all right. So, okay, let's do it. All right, the difference is this. Let's do this. I'm gonna copy this one. I'm gonna paste this. I'm gonna call this show array 2. Okay, I'm gonna get rid of the static. Okay, and now I'm going to try to call show array 2 just like I did. First of all, let's make sure this thing works. Right? So this works so far. I messed something up. One more time. Right? Let me show you the array. There it is. Array is this, 3, 4, 300, to whatever I changed it, right? Okay, so you're saying, what's the difference between this and the thing with the dot? Here's the dot thing. If I try to do show array 2, I'm just going to copy this whole thing, right? The only thing that was different of in the other one is it had a 2, right?
Yeah.
Like that. Build it. Oops. It's not that. You need an object to call this method.
Oh, so I have to do. Like,
You have to make a whole. Right, I'm gonna have to make an object here. So this one here. So I can call this. Right. I can call this without an object because the method is static. Okay, that's the reason I made this thing static. And static is just this piece right here. The other one does not have static, and I can't call it like that, right? So I have to call this using an object. What's the name of the class? It's arrays. So it's arrays is new array or something like that is equal to new arrays. Oops, lowercase arrays parentheses, and then I have to go in there and have to do arrays dot. Oh, new array. New array. You sure?
It's behind the.
I know. Okay. Build it. Now it's happy. Happy like a hippo. And then we're going to run this thing again, and there you go. Now it works. But that's why I had it as static. Good question. Okay. Right. So calling a method. Sure.
If you do it as an object, can you make it so that the function doesn't need an argument?
No, because you need to send the argument. You need to see it. And by the way, what's an argument? This here's my argument, right? This is the argument, right? This is my argument. If I don't send an argument, how would it know what it's trying to show? I need to send something. There is ways, I guess, if you have.
And like for all the data structure stuff, I haven't been sending.
The data structure stuff is different. You have the array defined like right here inside of the class.
It's like a constructor.
No. The variable that you have in the class, let's say you have an int x, something like that, right? That belongs to the whole class,
Okay.
and the class can look at it. But if it is not part of the class, which is what we have, you can't do that.
Just in the main.
Yeah.
Okay.
Yeah, man. Okay? Any other questions? Okay. So, what else? Right? So sending an array into a function or a method. The cool thing about Java that I really like is it does not have any pointers. Right? So remember in C++ you have to use a pointer if you want to change the thing and all that kind of stuff.
It's funny you say that because when we were at Silicon Hacks, I was trying to use a pointer, and I asked Roberto, I'm like, Roberto, is there like can I do a pointer in Java? I'm like, well, I asked him, how do I do a pointer in Java? And he looks at me and he's like, I don't think there are pointers.
No, there are no pointers. They got rid of pointers. They're like, you know what? Pointers suck. Let's just get rid of them. And it's brilliant. I love it. Right? And that's why I prefer teaching data structures with Java than with C++.
But I was like, I don't know what I was doing, but I felt like I needed a pointer.
Yeah, you would need a pointer if it was a C++ thing, but no, Java doesn't have that. There's ways to do it without a pointer. Okay.
To be fair, I had only started learning Java 3 days ago.
I know. Okay, so, but keep in mind, if I am sending the whole array, the way I'm doing it right here, it is actually the same as sending it as a pointer. So if you do any kind of a change to this array inside of that method, right, it will change this here also. So let me see if I have a changer in fatmax. No, I don't have it. Some array, I don't have it. No change.
Have it make a method that does the sort and then sort.
Yeah, that's right. There you go. That's the sort. Right. So I can grab this thing here. I'm going to grab my bubble sort, which I have already written. I'm not going to write it again. I'm going to go in there. I'm going to throw in my bubble sort right here. There you go. Right. So bubble sort takes some other array B. Okay. And I'm going to do sort E. Right. So we already saw that the array is 3, 4, 1, 300, right? The next thing I'm going to do is, what do I call it? Bubble sort. Go in there. I know I'm good with names. So I go in there, and we're going to do bubble sort E, just like that. And then I'm going to show you new array. Well, let's go this one, show array E, because it's shorter. All right, save it, build it, run this thing, and now my array is sorted. All right, so I send the array over into the method, and the method was able to change this array from the main. Okay, make sense? All right. So those are the basics. Let's have a look at what else I have to tell you. All right. Oh, and yeah, and if you're sending a specific array element like this, then the method itself has to take an integer parameter, just a single integer, not a whole array. Okay? And that's what this example is here. Array lists. Array list is a kind of an array that's in Java. C++ calls them vectors, right? And it's an array which can expand its size. So if you want to have an array of 10 and then later on you decide to add another 5, you can use an array list. It can change its size. Okay? Two-dimensional arrays. Right? Two-dimensional arrays are just like an Excel spreadsheet. Right? So if you open up the Excel spreadsheet, you have rows, you have columns. Right? That's what a two-dimensional array is. And let's have a look at this thing real quick. So it looks like this. Right? It's got a bunch of extra curly brackets in there. Let me line this thing up, hopefully. Okay? And this is important. You need to understand this because for the final project, I'm going to ask you to do a tic-tac-toe game which uses a two-dimensional array of buttons. Right? So this is a two-dimensional array, right? This is your row. These are your columns, right? So let's have a look at the different things in the array. So I'm going to go in there. I'm going to do a system out println, and let's say I want to show this value, right? So I'm going to go in there. I'm going to do square brackets val square 0 square bracket 0 is equal to. I'm just going to copy this. Plus, paste that in there, semicolon, save it. Okay, so this should show me the value 8, hopefully, right? Let's have a look, build it, go to the command line, run it, and there it is, there's the 0. Okay, so it's the same thing. 0 refers to this row, this second 0 refers to this column. Okay, so let's say I want to show the 52. You help me with this thing. What do I do?
1, not 1, 0.
So this one is 0. The second one is what? 3. All right, so let's put some numbers in there. Oops. Whoops. So this is 0, 1, 2, 3. All right, so I'm trying to show the 52. And then, by the way, this is 0, 1, 2, right? So I'm going after this one, which is 0, row 0, column 3. So, correct? 0, 3? Agreed? Well, I don't believe myself. Let's go in there and have a look. There you go. We pulled the 52. Okay, let's say I want to go to 25. How do I get the 25? How do I do that? 2, 1, right? 2, 1, 2, 1. Save it. Build it. Oops. Forgot my S. Come on, Marissa. Supposed to catch that. Alright. There you go. So now you get the 25. Okay? We can use a loop to go through this array also. Actually, we're going to have to use 2 loops. Alright? So I'm going to go do this. I'm going to say, I probably have it somewhere in there. Do I? No, that's not it. You can look at the book for some examples. Let's see if I have some examples in here. Oh, there is the example. I'm going to grab this thing here. Copy that. Throw it in there. Here. Paste. So I have one loop. Inside that loop, I'm going to have another loop. Right? So the first one is, and I'm going to call it val, because that's what this one is called, right? Val, not nums. Val. Okay? So the first loop happens val that length times. These are your columns. So these are these numbers here, right? These numbers is this loop. Okay? This other one here is, I'm saying val square brackets I that length. What is that going to get me? That's going to give me my j's, right? So let me put this. These are the j's. And this stuff here, these are my i's. Okay? All right. Let's hope it works. So I'm going to grab this thing here now. Copy this. It's going to look ugly, but I don't care. I'm just going to throw them all in there. All right? I don't have time to mess with it too much. So I'll just do something like that, right? So it's just going to spit all the numbers, 8, 16, 9, 52, 3, 15, 27, 6, 7, 25, all of them on the same row. Okay? If it works. In fact, I can get rid of the curly brackets because Marissa hates.
That's not true. I just use
She
them
hates
even
curly
when
brackets.
I use them when I don't have to. It was just a question.
All right, just for you. No curly brackets, all right? Calm down. So run it. Ooh, what did I do? J++, can't find J. Did I mess up? Wait, what?
I didn't put int J.
Thank you, Marissa. Int I. And J. Build it. And go back to this. Eesh.
Yeah,
What did I
your
do?
issue is you had 0, 0.
Oh, I have 0, 0. See, I'm lost without Marissa. I can't figure out how to teach the class.
Yeah, like.
All right, so I run it. There you go. 8, 16, 9, 52. That's the first one. Then we have 3, 15, 27, 6. Then we have 7, 25, 2, and 10, right? So bottom line is, when you have a two-dimensional array, which is what this thing here is, right? Two-dimensional, did I spell it right? Array, right? Two-dimensional array is this, right? So the I is columns, and the J is, wait, sorry, the other way. These are rows, and these are columns, right? So you can simplify going through the array and looking at different things, and that's what you should be doing for the final project. Question?
I have a tangent question.
What's up?
Oh, well, tic-tac-toe is really boring, but there's like an interesting way to play tic-tac-toe.
Okay, you can do something else.
Hmm?
Wait, always win?
No. No. It's actually really interesting. Finish your thing and then I will.
Okay, all right. That way, not everybody's listening to the video as we're having a conversation. Okay, thank you, Marissa. So that is pretty much all I have to tell you about arrays, right? I told you my joke, and there's some other ones in here. If you want to, you can do things with arrays, with differential equations or matrices. Sorry, this is not. Well, I guess you have matrices in different.
Linear algebra.
Linear algebra is what I meant, right? So you can do linear algebra problems. I think there's some matrices in differential equations, no?
Yeah, eigenvalues.
Whatever. So you can do things that are very time consuming if you're going to do them by hand, right? Matrix multiplication, matrix transposing a matrix, and all those different things that you're going to learn in your linear algebra, which is one of the hardest math classes you can take.
Okay, not beginning of linear algebra. Advanced linear algebra.
Whatever. Your linear algebra you took was not a hard one because your professor was just not doing a good job or whatever. That's why she didn't do a very good job. She should have made it extra hard.